Okay, so let's start chapters 9 and section 5, tangents. You've got some new vocabulary today. You've got what is a tangent? Well, a tangent is any line that touches a circle or intersects with the circle at just one point. Remember that, it's only one point. And where it actually touches is actually the point of tangency. And then when you've got more than, where there's more than one line, they will have common tangents. So basically we're looking at two circles where you can join them together. Think of a bicycle chain on a bicycle. You know, you've got the small cog at the back and the big cog at the front, and obviously your chain all the time is making tangents with both of them, so they've both got common tangents. So here we are with example 1. I've skipped to number 9 because the question number 1 is only really one of them, and I want to give you a focus on a few of them. So let's have a look at number 9. Okay, so again, you've got to start looking out of the box. So look for things a bit extra. So for question number 9, you've got to find out if there are any common tangents, but if there isn't any, you just write no common tangents. Just put no, it's a lot easier. But let's have a look at number 9. What looks like a snowman? Well, starting here, you've got a tangent that goes like that. Okay, well, obviously you've got symmetric, so you know you've got one the other side. So there's the second one. Okay, and then have you got any others? Well, yes, you've actually got the common tangent that goes through the middle. So make sure you've got each and every one of them if you can. All right. Skipping on, well, if you look at number 10, you've got concentric circles there. Well, if you've got concentric circles, they're all bigger and different sizes, but they've all got the same center, so you know that you're not going to have any common tangents there, so just write no. Okay, and then carry on with question 11 and question number 12. Okay, in example 2, identifying a tangent. Well, how do you know you've got a tangent? Well, purely and simply, if you have a tangent, then it automatically makes a right angle with the radius, because obviously the radius is going from the center to the circumference of the circle, and your tangent is going to be touching it, so you are going to be making a right angle. So if you look at the diagram here, if you make a triangle, what you've got to decide is it a right angle triangle? If it is, then it has to be a tangent. If it isn't, then it cannot be. So for instance, if you do, and be careful, all right? So your shorter side is 8, your longer side is 15, but your hypotenuse is actually 17. It's the 9 that goes from K to the circumference of the circle, and then don't forget to add on the radius. So 9 plus 8 will make 17. And if you do Pythagoras, 8 squared is 15, and 15 squared is 225, and if you add those together, you make 289, and 17 squared is 289. It is a right angle triangle, so it definitely is a tangent. So as you know, we're going back a couple of chapters now. You've got to work out, I mean, you've got to use Pythagoras in order to answer questions that's in example 2, but think back to your triples, okay? Don't forget your triples are 3, 4, 5. They're 5, 12 and 13. There are 8, 15 and 17, and then you've got your 7, 24 and 25. Okay, so if you can remember your triples, it makes questions like this so much easier. So for instance, on question 13, you've got a 7, 24 and 25 triangle. Well, you know it's a Pythagorean triple, it's this one here. So you know that question 13 is definitely, okay, to justify it, Pythagoras, you can just put triple. Make it simple for yourself, okay? Now when you move on to the others, don't forget, let's skip to number 15. You've got 5 squared plus 8 squared, and does that equal 8 squared? All right, well, you work that one out to make your mind up. Well, if you've already got 8 squared and 8 squared, and there's no way that can possibly be, so purely and simply the answer to question number 15 is no. All right, now finding the missing values. Well, as you can look at the diagram here, your radius is missing. It's x in this case. And as you can see from the example that you've got, the hypotenuse is 8 plus x, and you have to square it. Okay, well, go back to what we did in Algebra 1, or what you did in Algebra 1. When you have got a square, what you do is you square it, you double it, and then you square it. So to simplify that is going to be x squared plus 16x plus 64. The quickest way, square it, double it, square it. Okay, so even though you've got what looks like a quadratic, as you look at this line here, you will see that from that line to the next line, your x squareds cancelled out, and then it just purely and simply becomes a simple algebraic expression solved for x. And as you can see in example 4, using congruent triangle tangents to find measures, again, you know that you've just got to find the variable in here, and if you have got tangents from one point, which in this case is B, then both the tangents from B to the tangent A and C must be congruent. So all you do is you set them up to equal each other, use basic algebra to solve for x. But again, just make sure, plug it back into both. If you plug it back into both and you get the same answer, your algebra is correct. Okay, so plug it back into both. All right, so I'm going to jump to question number 5. Because that's the one with the radius that's missing. Pythagoras again, a squared plus b squared equals c squared. Well, a squared in this case is going to be ab, so that's going to be x squared. The longer leg is going to equal 30, which is 30 squared. And the hypotenuse is going to be x, which is the radius, plus 18. And we're going to square all of that as well. Remember what I said a few minutes ago, square it, double it, square it. So you've got x squared plus 900 is equal to, square it is x squared, double it is 36x, and 18 squared is 324. 324, okay. Your x squares are going to cancel out. If I subtract 324 from 900, so we've got 36x, I'm moving the variable to the front. So 36x equals 576. So x is going to equal 576 divided by 576 divided by 36. And your solution is 16. And then finally, example 5. Don't forget, from any point to the tangent must be congruent. Okay, so even though it doesn't sort of show it too much on the diagram, you will see that it does. So for instance, from E to B, you're told that it's 7 feet. Well, from B to F, from there to there is also 7 feet, which means that from C to F must be 3 feet, because the 3 feet plus the 7 will make the 10. So if this is 3 feet, CD also has to be 3 feet. And then if A to D is 8 feet, A to E must be 8 feet. Okay, so everything from a point to the tangent must be congruent. So, okay, first of all, we've got two sections for number 8, find x for A and then find the perimeter. Well, you know that from O to L and L to N must be congruent, so you can put in your equation. So 4x minus 9 equals x plus 3. Continue to solve, so subtract x from both sides, so 3x minus 9 equals 3. And add 9 to both sides, 3x equals 12. Divide through by 3, x equals 4. So now we've found x, but don't forget we've got to plug it back in again. Okay, so don't forget, if you do x equals 4, so from L to N, Ln, is equal to x plus 3, which is the same as saying 4 plus 3, which makes 4 plus 3 makes 7. So we know that both of these are 7. We also know that from J to O and J to M must be congruent, so that must be 12. And from M to K is 7, so from K to N has to be 7. So basically, each side you've got 4 lots of 7, so 4 times 7. And you're going to add on to that 2 times 12, which is 24. So 28 plus 24 is equal to 52. So the perimeter is 52.